All right, welcome back, guys and gals, to another edition of fun-filled, action-packed, flipped geometry classroom videos. So here it is. Today we're going to be going over count them up, two whole examples of triangle congruency, two new rules. So today we're going to kick it off with angle, side, angle. So let's take a look at this new triangle congruence, another way to show that two triangles are congruent. So let's take a little read here. If two angles and the included side of one triangle are congruent to two angles and an included side of another triangle, then the triangles are congruent. So let's take a look at our picture, our diagram here, and write the appropriate labels. So included means the side between the angles, between. So if we need an angle, angle A is congruent to angle, which one is it congruent to? D. And then we need a side. I don't know why this thing looks messed up. Our side is AB. And AB is congruent to, which one is AB congruent to? DE, right here, congruent to DE. And then our second angle, right here, B and E. So angle B is congruent to angle E. Then triangle ABC is congruent to triangle, how am I going to label it? DEF. And there we have it. This is this angle, side, angle way to prove that two triangles are congruent. You have one angle, the side, and then the other angle. So let's go into some examples to see how to use angle, side, angle. Here are the proofs. So once again, realizing this proves, what are you trying to prove? You're trying to prove that triangle QRS. I'm actually going to separate these two triangles because they're on top of each other and it's kind of hard to see that. So QRS, that's something like this. Q, R, and S is congruent to triangle QTS, which looks something like this. Q, T, S. Notice that both of these triangles are using the Q and the S still, okay? So what we want to show is that this triangle has an angle, a side, and the angle congruent to each other so that we can prove that these two triangles are actually congruent to each other. So let's look at the given first. First they tell us that SQ bisects, so SQ is this line right here. And it's telling us that that bisects RQT. RQT is right, RQT. Bisects our angle RQT. What does that say about angle RQS and angle TQS? That's saying that angle RQS and angle TQS are congruent. So if I draw that on the two triangles I've drawn on the side, RQS is congruent to TQS. That's the whole reason they would tell me that SQ bisects RQT. But they also say that SQ bisects, what else does it bisect? RQ bisects, SQ bisects RST, that's RST. So what does that say about angle RSQ and angle TSQ? That means that angle RSQ and TSQ are also congruent. So if I draw that on my triangles on the side over here, RSQ is right there and TSQ is right here. So they told us that SQ bisects these two angles, which means the two smaller angles that total to make up the full angle are congruent. Alright, so we have two angles, and do they share a side? Take a look at the picture over here, the original triangle. Notice that they both use this line QS as the side. So triangle QRS, look at my side picture, uses QS, and triangle TQTS also uses QS. So that means that this side is going to be congruent on both of them. Because both of these triangles are using the exact same side, of course the length is going to be congruent on each of these triangles. So now let's fill in our proof table. We can already see from our diagram that we've drawn and the things that we've gotten from the given that these two triangles will in fact be congruent. So let's fill in the proof table. Step 1, SQ bisects RQT and angle RST. How do we know that? It's in the given. Number 2, angle RQS is congruent to angle TQS. Take a look at that. Angle RQS is congruent to angle TQS. How do we know that? How do we know these angles? Look, we drew it on our diagram, and that's because it is the definition of bisect. That's why they told us that SQ bisects RQT. And then we also have that angle RSQ right here is congruent to angle TSQ. How do we know that? Once again, it's the definition of bisect. Remember, if you don't want to write it again, you can just use the little quotes with nothing in between. All right. Step 4, QS is congruent to QS because remember, both of our triangles, look, right here and right here, both of them are using QS, the side QS from the original pasted together triangles. And so we need to show that it is in fact congruent to itself. And what's that property called? The reflexive property. Now, as you can see in our proof, we have one angle, two angles, and then one side. So we got the angle, side, angle, and we have proved that these two triangles are in fact congruent by angle, side, angle. And we have finished our first one. So let's go to the next one. Number 3, here we go. So once again, let's start by looking at our given and seeing what kind of conclusions we can draw from that. So let's take a look. First, they tell us that angle BAC, that's right here, is congruent to angle DEC. That's over here. And then they tell us that C is the midpoint of AE. Why would they tell me that C is the midpoint of AE? That's because they want us to know that AC, take a look, AC right here, is congruent to CE over here. That's the whole point of telling us that it's the midpoint. That's the definition of the midpoint. AC is congruent to CE. So we can know that from the midpoint. And now it looks like we have an angle, a side, and where's our last angle? Can you see it in this picture? It's gonna be right, so this one's congruent to this side, and it's gonna be right here at the middle. Why are these two angles congruent to each other? Because they're vertical angles, and vertical angles are always congruent. So now it looks like we have what we need. We have an angle, a side, and an angle, so let's fill in the proof table. Step 1, angle BAC is congruent to angle DEC. Where's that? It's in the given. Step 2, C is the midpoint of AE. Where's that? Also in the given. I need to burp. Step 3, AC is congruent to CE, or they wrote EC, but that's up here. And how do we get that? That's the definition of the midpoint. Remember, that's the reason they told us the midpoint. And then, number 4, angle BCA is congruent, that's over here, BCA, is congruent to angle DCE, that's right here. How do we know that? Because of the vertical angles. Vertical angles. And then now we have, look, one angle, one side, second angle. We have the angle, side, angle. So by angle, side, angle, we know that triangle ABC is congruent to triangle EDC. All right, let's move on to the second rule of the day. This is a little marathon, guys, but we're gonna get through it together. So let's look at the second one. Prove that two right triangles are actually congruent to each other. So this only works with right triangles. It's called the hypotenuse leg. So what do you think you're gonna be looking for? You're gonna be looking for a congruent hypotenuse and a congruent leg between two triangles. So if the hypotenuse and a leg of one triangle is congruent to the hypotenuse and a leg of another right triangle, these have to be right triangles, then the triangles are congruent. Look at the picture. These are both right triangles. There's a congruent hypotenuse and a congruent leg. It can be either leg. It doesn't have to be the one that's going straight up. It can be either one. But in this case, it's the one going straight up and down. So in this diagram, let's write it out. If the hypotenuse, where the hypotenuse, it's going to be BC is congruent to EF. That's the two hypotenuses. And then where's our legs? AB, it's right here, is congruent to DE. Then triangle ABC is congruent to triangle DEF. So all we're looking for is a right triangle, hypotenuses that are congruent, and one leg that's congruent. And then we can prove. That's enough to prove that these two triangles, these two right triangles, are congruent. So let's do some examples. Let's take a look right here. Same thing as always. Go into the given and label your picture. So let's draw it into two pictures once again. Boom, boom, boom. L, P, M, and then M's up here, P's right here, and N is over here. Okay, so take a look. Given L, M, P, and triangle M, N, P are right triangles. That means look at the right angle. It's right here. So I'm going to go ahead and draw the right angle right here. Right away from knowing that's a right angle, you can think about, can I find hypotenuse leg? Then they tell us that ML, that's right here, is congruent to MN, that's right here. So these two sides are congruent. And lastly, we need one leg. Is there a leg that's congruent? Look how they both share MP. They're both using this line MP. So of course that's going to be congruent to itself. Look, MP is congruent to MP. Now you can see that we have right triangles, the hypotenuses are congruent, and we have one leg that's congruent, so that's enough to show that these two triangles are congruent. So let's fill in the proof table. Triangle LMP and triangle MNP are right triangles. That's in the given. ML is congruent to MN. That's also in the given. And step 3, MP is congruent to MP. What is that property called? The reflexive property. And lastly, that's enough because we have a hypotenuse and a leg and we know the right triangles, so they are congruent. These two triangles are congruent by the hypotenuse legs, or HL. And that's it. Let's go to the next example. Alrighty, wow, this is a little, why does this look funny? Okay. Alright, given triangle, wait a second, what the, okay. Given triangle WVX and triangle YZX. YZX are right triangles, then WV is congruent to YZ. So let's label it. So first of all, these are right triangles, so let's just pick a right angle. It's right here. Looks like it's going to be right there and right there. So that we know they're right triangles. WV, that's right here, is congruent to YZ. That's right there. And X is the midpoint of WY. Why would they tell you that? Because they want you to know that WX is congruent to XY. So let's go ahead and write that. WX, oh, that's from the midpoint, so WX is congruent to XY. Alright, now let's fill in the proof table. We already have the statements, we just need to write the reasons. So, triangle WVX and triangle YZX are right triangles. How do we know that? That's in the given. Next one, WV is congruent to YZ. That's also right here in the given. Number 3, X is the midpoint of WY. Where's that? That's also in the given. Step 4, WX is congruent to XY. Look, I wrote it right here. Why is that? Because they told me X is the midpoint of WY. So what's the reason? It's the definition of midpoint. And lastly, we have, look, we have the right triangles, we have the hypotenuses, and we have one leg. So these two triangles are congruent by hypotenuse leg. We are done. That's going to be the end of this one. I'll see you on the next one. Peace out.